Hello again. In this part we will be looking at exceptions. Exceptions are a powerful and common mechanism to report that something went wrong. Exceptions allow us to immediately exit the scope and unwind the stack until someone catches the exception. This allows us to keep the API very simple and focus on the happy path of the function. If something goes wrong when reading a file, an exception is thrown and we will not return the contents of the file. On the other hand, handling exceptions may be error-prone. This is partly because exceptions are not part of the function signature. In other words, unless very clearly documented, we cannot know which exact exceptions a function may throw just by looking at its signature. To make things even trickier, exceptions may be thrown by functions that the functions we are calling invoke. This means that if we want to be granular about the exceptions we want to handle, we need to potentially catch a large number of them. That being said, exceptions aside, you should be using patterns like RAII to make sure that resources are always released properly. Exceptions may also come with a performance penalty if they are thrown frequently. It is not uncommon for C++ code to be compiled with the exceptions disabled. Let's look at an example of how we can use exceptions to report errors. We can see that the readFile function throws a file not found exception if an error is encountered. Then, in the caller, we use a try-catch block to handle the exception. If an exception is thrown, the content variable is never returned and we end up in the catch block. As a result, in the try block, we can focus on the happy path and not worry about error handling. Whenever we access the content, we know that it is valid. Let's look at another example. Exceptions may make sense when you have deep call stacks and you want to avoid checking for unrecoverable errors in multiple places and then only propagating them up the stack. Your code becomes unnecessarily complex. If you cannot do anything about an error, then do consider throwing an exception instead of bloating your code by propagating errors just to exit gracefully. There are many best practices when it comes to exceptions in the C++ core guidelines. In my opinion, there are 3 things to keep in mind. First, develop a strategy when it comes to error handling and exceptions early in the project. One of the worst things you can do is to mix techniques and make it unclear for developers when exceptions may be thrown. Second, use exceptions to report exceptional errors. An exception should signal that something horrible and unexpected has happened. It should not be used to report errors that are somewhat common. For example, exceptions may be thrown for a constructor not being able to construct an object due to failure to allocate memory. Another example could be a function that tries to get an out-of-bounds element from a container. In these cases, you would want the exceptions to be thrown and this error to be escalated. Throwing exceptions for exceptional errors also means that you should not be handling exceptions in most places in your code either. Catch exceptions only when and if you can do something about them. Third, create your own exception types. They are more readable and allow your exceptions to not be confused with others. In this video, we looked at exceptions. We saw that exceptions are a powerful mechanism to report errors. They allow us to immediately exit the scope and unwind the stack until someone catches the exception. This allows us to keep the API very simple and focus on the happy path of the function. On the other hand, handling exceptions can be error-prone and may come with a performance penalty if they are thrown in too many places. Use exceptions to report exceptional errors and avoid catching them unless you can do something about them. So, what happens if we may not or cannot throw exceptions? A value needs to be returned, but what should it be to make sure that wrong code is hard to write? What should the type be to make the error unignorable and unambiguous? The rest of this course will be about exploring the different options we have, so stick around to find out.